Let's see precision rectifier using op-amp. So this is the precision rectifier circuit by using op-amp. So there is a diode which is connected in the output side of the op-amp. So parallelly one load resistor is connected at the output side. So this is the input voltage, and by using the precision rectifier we are getting an output like this. So when diode is on condition, the same output will be there. When diode is in off condition, there is no output. The limitations of the ordinary diode is it cannot be able to rectify the voltages below 0.6 volt. That is, the cut-in voltage is less than approximately less than or equal to 0.6 volt. Hence, the precision rectifier is used in feedback loop of the op-amp, which can be able to rectify the input signal of the order of millivolt. In a circuit, the cut-in voltage V gamma, that is divided by open loop gain 0.6 divided by 10 power 4 approximately, that is equal to 60 microvolt. When diode is in on condition, input voltage is greater than cut-in voltage divided by open loop gain. Input voltage is positive. When the input voltage is greater than 0, the output voltage will be similar to input voltage, that is equal to Vi. If the diode is in off condition, it is the reverse process. Input voltage less than cut-in voltage divided by open loop gain. So when that time that is equal to 0, output will be 0. The applications of precision diode is half-wave rectifier, full-wave rectifier, peak value detector, clipper and clamper. So now the half-wave rectifier, this is the half-wave rectifier circuit. There are two diodes are connected, diode 1 and diode 2. So this is the output voltage of half-wave rectifier by using for precision diode. So here if the diode 1 is on, diode 2 is off, and that time input output voltage is 0. If the diode 1 is off, diode 2 is on, when that time output voltage is similar to input voltage but in opposite reverse direction. If the input voltage is greater than 0, diode 1 is on condition, diode 2 is in off condition. When that time diode 2 is in reverse bias condition, the output voltage is negative, that is equal to 0 but in negative. No current flow through the feedback resistor and input current will be flow through the diode 1. It is in non-inverting mode. If the input voltage is less than 0, diode 1 will be off, diode 2 will be on condition. When that time output voltage will be positive, RF equal to R1, the input current will be flow through the diode 2. When that time circuit will be access as an inverter. The limitations are main important limitations is slew rate. Next one is full wave rectifier. This is the circuit diagram of full wave rectifier. There are two diodes, diode 1 and diode 2 are seriously connected and parallel with output voltage of the output of the op-amp. There are two op-amps used, A1 and A2. If the VA greater than 0, diode 1 will be on condition, diode 2 will be off condition. Amplifier 1 and amplifier 2 will be acts as an inverter. When that time output voltage equal to 0. Here the circuit is remodified and drawn here. Equation number 2, the condition is 2. Second condition, that is VA less than 0. When that time D1 is off, that is diode 1 is in off condition, diode 2 is in on condition. When that time the voltage flow will be through amplifier 1. It is considered as voltage, that is V. The voltage across amplifier 2, that is equal to 0. Now the remodified circuit is drawn here. By using this circuit we will do the analysis for the second case. By applying KCL node A, we will get capital V, that is equal to minus 2 by 3, intermediate voltage, that is equal to minus 2 by 3 into input voltage, equation number 1. So according to the equation number 1, the primary circuit is remodified. So we know that the voltage gain, that is equal to 1 plus RF divided by R equal to 1 plus R divided by 2R for non-inverting amplifier, that is V0 output voltage equal to minus Vi. The third condition V naught equal, if both V naught and Vi equal, V naught equal to Vi, means this is the input output character, input output waveform. And the peak detector is used to measure the peak value of the keep on verifying signal. So this is the circuit of peak detector. At the output side of an op amp, there is one diode is connected, and the cathode end of the diode is connected to the capacitor. Parallelly, one MOSFET switch is there with the capacitor. If the input voltage is greater than capacitor voltage, the diode will be in forward bias condition. Output will be flow through follow VI, which means it is acts in that time, which will be acts as a voltage follower till VI less than VC. So VI less than VC, diode will be in reverse bias condition. Capacitor will be holds the charge. So here keep on varying the signal. We can intermediately measure the maximum voltage, peak voltage, by change the direction of the diode. It is work as positive peak detector and a negative peak detector. The applications of peak detector is test and measurement instruments, amplitude modulation, and clippers. So there are two types, positive clipper and negative clipper, based on the diode direction. So this is the circuit diagram, and this is the input output waveforms for the positive clipper and negative clipper. Here, according to the reference voltage, the clipping operation will be done. So in the positive clipper, if the reference voltage is in positive, the upper portion will be clipped. If the reference voltage is fixed in negative side, the below the reference voltage will be as it is. Above the negative reference voltage will be removed, clipped. So the opposite operation will be done in the negative clipper. So V less than reference voltage means diode will be on condition. When the time V0 will be follows the Vi till Vi less than or equal to reference voltage. So the Vi greater than reference voltage means diode will be in off condition. Output voltage will be reference voltage. So clampers. So here clamper is otherwise called as peak clamper or DC inserter or DC restorer. The circuit is used to add a desired DC level to the output voltage. Here output is clamped to the desired DC level. DC level is clamped in if it is in the negative clamper, negative portion, or if it is a positive clamper, DC level will be clamped in positive portion. Here this is an input, so this is for positive clamper, this is for negative clamper. So the clamping is decided by reference voltage. This is the positive clamper circuit, and this is the negative clamper circuit, depends on the direction of the diode. So this is about clippers, clampers, and the peak detectors.